So hey guys, how are you? Welcome back to the channel. Today is day 27 of upskilling myself, and today I solved 3 DSA problems. So let's move on to the DSA part. So the first problem was single number 3. So what we have to do was we have been given an array of numbers. Let's say 1, 2, 1, 3, 2, and 5, and we have to return an array of the pair of two numbers such that these two occur just once. Okay, so these two numbers should be unique. Okay, so in this case, if you see, 3 is unique and 5 is unique, so we have to return the pair of the unique numbers, right? So first of all, we XOR every number so that we get the XOR of all of this array. And as you know, that 1 and 1 XOR is 0, 2 and 2 XOR is 0, so we will get the XOR of 3 and 5 as our output, right? So we'll do the XOR, and XOR all will be equals to the XOR of 3 and 5. Okay, we have to keep that in mind. So now in this case, we'll get a difference bit, right? So the bit which is different in these two, we want to get that particular bit. So what we'll do is we'll AND the XOR with the negative of XOR, right? And this XOR should be an unsigned int so that it does not throw any compilation error. Then we define A as 0 and B as 0. Then we traverse the whole array, and we have to segregate the array based on two groups. One group whose AND of the difference bit would be equals to 1, and another whose AND with the difference bit will be equals to 0. Okay, so if the difference bit and num is equals to 1, then we have to add it into this particular group over here, and else we have to add this in this group. And as you know, the similar numbers cancel out each other, so we'll get 3 or 5 over here and 3 or 5 over here, so we'll get two different numbers, and then we return the pair of these. Okay, so the second problem is minimum size subarray sum. So we have been given an array, and we have to return the length of the subarray such that its target would be 7. So if you see 4 and 3, the sum of 4 and 3 is equals to 7, and the length of the subarray is 2, right? What we need to do is, first of all, we initialize two pointers, which is left and right. To manage the sliding window, we have to solve it using the sliding window, and we have to use dynamic sliding window because there is no fixed size, so we can't use the regular sliding window. Okay, so we define the size, then we initialize left and sum as 0. We start from the right as 0. Then we set the minimum length as int min. Then we'll traverse the whole array, and we add the number into the sum. So now if the sum is greater than or equals to target, then we have to find the minimum length, right? After we get the minimum length, we have to reduce the leftmost element from the sum, and again check if the sum is greater than or equals to target, and then we get the minimum length. And after all this, we have to return the min length. So if the min length is equals to int max, which means that we didn't find any, so we return 0, else we return the min length. So the final problem was max consecutive ones, 3. So it is the third sub problem of this type of problems. So we have been given a binary array of nums. So if you see, we have been given 1, 1, 1, 0, 0, 0, 1, 1, 1, 1, and 0. And we have given k is equals to 0. Sorry, k is given as 2. Okay, so we have to output a sub array where we can change k number of zeros. We can change k number of zeros, and we'll get a sub array who contains all of ones. Okay, so in this case, if you see, this over here is of size 6, and we can change these two zeros as k is 2, and we'll get a size of 6 where all of the subarray elements are 1. Okay, so if you see, we have solved the a type of similar question which was like I guess AB and AB, and we can change like k elements, and we can get the maximum subarray where all the elements are similar. So it's the same kind of, but here the thing was we can change any element, and here the thing is that we can only change zeros. So we just have to keep the track of zeros. So yeah, it's simple. We get the size, then we initialize left as 0, right as 0, then we set max length as 0, and we have to calculate the 0 count, right? Earlier in this problem over here, we were calculating the frequency of every character, right? But here we just have to calculate about 0. So we set 0 count as 0, then we traverse the whole array, and then if the nums of right, that means if the num that we are iterating on is equals to 0, then we increment the 0 count. Then while the 0 count is greater than k, it should be less than or equals to k. So while it's greater than k, we have to subtract the nums from here. So if the num is 0, we have to reduce the 0 count, else we just have to iterate forward. Okay, then we calculate the max length using the max of max length and right minus left plus 1, which is the length of this subarray. Okay, and then we increment the right, and then we return the max length. Then for the development part, I did some internship work, then I did some YouTube stuff, and then I did the revision of all the DSA problems that I solved till now. So thank you guys for watching and see you on day 28.